Worksheet pH calculations. First, you're going to fill in the blanks up at the top of your worksheet with words that are in your notes, either in the note guide that you were given or in the note-taking that you did earlier in your packet from watching the video. And then you're going to do some problems afterward on this page and the next where you are to determine the pH or determine the concentration, the molarity, of a substance, an acid or base, depending on its pH. So you're going to use one to solve for the other. And what I'm going to do, you may want to grab yourself a piece of scratch paper and write this down as I do it, but what I've done, I've written down just some sample problems for us to do together so you can see what it is that we need to do to find pH if we know the molarity, and then we'll do a couple of problems where we have to find the concentration. The whole idea of pH is this kind of means the power of hydrogen. It's how concentrated the hydrogen is in our solution. So remember, in an acid we have a lot of hydrogen, whereas in a base we're not going to have as much hydrogen ions, we're going to have more hydroxide ions, this OH. And our pH scale, remember from our notes, goes from 0 up to 14, and these are powers of 10. So that's kind of what we're talking about here with the power of hydrogen. These are powers of 10. It means that as I go this direction, from a pH of 6 to a pH of 5, means that this acid with a pH of 5 would be 10 times stronger of an acid than one with pH of 6. A pH of 4 would be 100 times stronger than a pH of 6 because this is 10 times stronger than this, and the 4 is 10 times stronger than 5, so it's 10 times stronger times 10 times stronger. So you can see how it gets much more concentrated as we move this direction on our pH scale toward an acid, and it's the same thing with bases. A base is 10 times stronger each time we move up 1 on our pH scale. So the way that you calculate pH is using this formula right here. It's the negative log, that's logarithm, of the H positive concentration of our solution. So the H positive concentration is our hydrogen ion concentration, and when I do this I get pH. So what we're going to do here is the molarity tells me the concentration of this substance in solution. Now, because I have one hydrogen in this hydrochloric acid, it means that when this breaks up, when it dissolves and dissociates, I'm going to have one H for every HCl in my solution, because there's only one H in this HCl. So when this breaks apart, my H concentration will be the same as my concentration of HCl. So what I'm going to do, this now, because I only have one hydrogen ion in HCl, this is my hydrogen ion concentration. So all I have to do is plug in the negative logarithm of 0.02, and that will give me my pH. So I'm going to take my calculator, and you're going to plug this in exactly as it shows here. Negative log, so the negative is right here. Don't use the minus, use negative. Negative log, logarithm, and it already opens up my parentheses, and I'm going to put in my 0.02 and close my parentheses before I hit my equal sign, and it gives me a pH of 1.699 because I'm going to round that up. So 1.699 is my pH. Alright, that's all you have to do for this one. Now when I look at the next one, when this dissolves in solution, it's not just one hydrogen for every piece of this compound, right? This is H2S. It means when this breaks apart, there will be two H's for every H2S that broke apart. So my concentration of hydrogen will be double what the concentration of H2S is in this solution. So I can't just put in 0.045 into my formula here. I have to double it because I'll have twice as many hydrogens in my solution when this breaks apart. So I'm going to double this first. So I'm going to start off, I'm going to put my negative log, but I'm not going to put a 0.045 in here. I'm going to put 0.045 times 2, oops, clear that out, 0.045 times 2, and I get 0.09. And that will give me my pH. So I doubled my concentration before I take the negative log of it. So now I'll do the negative log of 0.09, and I get that the pH is 1.046 is my pH. So see how, since I had 2 of them in there and I have a higher concentration here, anyway, I end up with a lower pH because there's going to be more hydrogen ions in this solution. So my pH is lower because it's a stronger acid. It's closer to 1. Now, we have to do something a little different for bases. In your video that you watched, it had you do a method where you took the H positive ion concentration times the OH negative concentration is equal to 1 times 10 to the negative 14th. And this is one way to do it. I'm going to show you what I feel is a little bit easier of a method to do it. Rather than solve for your putting your OH negative in here and solving for your H positive concentration and then plugging it into pH, I'm going to have you solve for the POH, the power of hydroxide. So I'm going to have you do negative log of the OH minus, and that'll give you POH. Because what's cool about this is that your pH plus your POH have to equal 14, and it's a lot easier to just subtract to get 14, to get the difference from 14, than to have to divide with your scientific notation and get this little bitty number. So here's what we would do for hydroxide in our bases. So I have a concentration here. This shows me I have 1 OH in this base. So I'm going to do that same thing that I did here. I'm going to do negative log of this concentration, and that gives me POH because I've plugged in the concentration of OH, not the concentration of H. So I'm going to do the same thing I did before. Clear this out. Negative log of 0.015, and it gives me 1.82 is my POH. But I don't want to solve for POH. I want to find my pH. But I know that pH plus POH gives me 14. So if I subtract this from 14, 14 minus 1.82, it will give me my pH. So my pH is 12.18. Because my POH and my pH have to add to 14. So when I subtract my POH from 14, I'm left with pH. So here's my answer for this one. And remember, since we have a base, I know that my pH should be higher than 7. So when I ended up with this 1.82, I know that that can't be my pH, that's my POH, because 1.82 would be an acid. So I'm going to change this to find my pH, which would be greater than 7. Same thing down here as we did here. We had double the amount of hydrogen ions, and here we have double the amount of hydroxide ions when this dissociates. So I'm going to have to double this as well. So again, I'm going to find my POH, negative log of double this, 0.102, which would give me 0.204, and that gives me my POH, again, because I'm looking at the concentration of hydroxide here, and negative log of 0.204 gives me 0.69 is my POH. So this is showing me my POH, but I want to know pH. So I'm going to subtract this from 14. 14 minus 0.69 equals 13.31 gives me my pH, and that's what I'm looking for. So when you solve for pH, make sure that you're looking at the number of hydrogens in the acid or the number of hydroxides in the base. Take the negative log of that concentration and multiply it by however many of them you have. Solve for either pH or pOH, and then subtract from 14 if you found pOH to find your pH. Now the reverse of this, if I need to find concentration, if I'm finding the hydrogen ion concentration, what I'm going to have to do here is it'll give me a pH. Let's say I have a solution with a pH of 3.2 and I want to know the H plus concentration. So what I need to do is the opposite of what I was doing before. I had negative log of my H plus concentration gives me pH. So I want to do the opposite of this. I'm going to solve for my H plus. So first thing, I'm going to bring my negative to the other side. Don't worry about how I'm doing this, just look at what it is so that you understand why I did it. So the log of H plus is going to be the negative pH, and that means that to get rid of this logarithm, I need to take it to the other side. To do the opposite, I have to take the inverse logarithm, which means I'm going to do the second log of it. So my H plus concentration will be the inverse log, which is second log on your calculator, of the negative pH. Here's all you have to do for this. So if I have a pH of 3.2, then I'm going to take the inverse log of the negative pH. I said that my pH was 3.2, so I'm going to do the inverse log, which is second log of negative 3.2, and that gives me my hydrogen ion concentration. If you want this in scientific notation, remember you can always hit second and then this DRG, you see the SAI up above, to put it in scientific notation. Move your arrow over, hit enter, and it gives me 6.31 times 10 to the negative fourth. So my H plus would be 6.31 times 10 to the negative fourth. If you need to find the OH concentration, then you're going to do this part up here. So if I wanted to find my OH negative, I'm going to use this. So I know that my H plus times OH negative equals 1 times 10 to the negative 14th. I know this is my H plus because I just solved for it. So 6.31 times 10 to the negative 4th times my OH negative concentration equals 1 times 10 to the negative 14th. So I'm going to take this, clear this, 1 times 10 to the power of negative 14, and then divide that by, bring this over to the other side and divide, 6.31 times 10 to the negative 4th, and hit enter, and I get my OH, let me move this up so you can see it, OH negative concentration is 1.58 times 10 to the negative 11th. So when you're solving down here, you're going to use the inverse log to find your hydrogen ion concentration. Here you use the log, you'll use the negative log. So I hope you wrote these down somewhere so you can look back to them to figure out the problems that are on those pages. All right, it is a couple pages worth in this worksheet. So it starts here, determine pH, there's one H, determine pH, there's one H. Here we have two H's, and now we've changed to OH, 1 and 2 of them. And it goes on to the next page as well. You're still working on finding the pH or finding the concentration of the hydrogen or hydroxide. I know this is a little confusing at first, so if you do get stuck on any of this or do have any questions, please do come ask.